Well, the weather is actually turning active over the next few days, whether you live in Alabama or Mississippi. Taylor and I will get in there and discuss all of this incredible weather coming up only on the forecast with Stingray and TP. Welcome inside another edition of the Forecast with Stingray and TP. I am your host, Stephen Ray, and we're going to have a little bit of active weather coming up, not only overnight tonight, and then on the day on Friday as well. So let me go on ahead and get in here and let's break it all down, and let me pull up my co-host, Taylor Plott. Taylor, how are you doing today, sir?
Pretty good, Stephen. How are you doing?
I'm doing good, man, and we've got a lot of active weather to talk about here over the next few days in the South.
Yes, we do. So we've had a kind of a nice little lull in the activity. Not only is that allowing for some of the flooded areas and flooding concerns to go down, but unfortunately, yes, we're seeing a return of the active weather. It's springtime here in the South, so you know what that means. You get a lot more stormy weather coming our way.
Yep, so we've got two systems. One that is ongoing right now across Mississippi that's going to push through Alabama tonight. And then we've got another one that is creeping up for Friday. And the Friday one looks more significant right now.
Yeah, I've had my concerns just regarding the overall setup for this one that's happening today. Regarding there's a lot of limiting factors I saw in place, and sure enough, as it looks right now, things are. If you could get the storms to behave themselves, they've been behaving themselves so far tonight. But looking ahead to the one late Friday, going into the day on Saturday, that one does have a little bit more things going in favor of some strong, severe storms. But yet again, there's still a couple of limiting factors that I see being hinted at in the model guidance that if things go a certain way, kind of like what they're doing tonight, that one probably wouldn't be as potent as it could potentially be.
Well, let's go on ahead over here and show everybody the radar and what's going on right now.
Yeah, so what we got going on right now is we've got this kind of, I can't even say it's a line. It's more of a batch of showers and storms that is kind of it's somewhat forming a line. The cold front, the main cold front is still kind of back here. It's with this last little line here, back to the west of Memphis. So it's just now getting to the Little Rock area. But taking a little bit closer look, we can go to the take a look at the Memphis next round. We did have one severe thunderstorm warning that was just to the east of Memphis, and that has since been allowed to expire. But this is what I mean by it's almost not really a line. You've just got this batch. You've got these little areas here and there. We kind of got a little bit of a line here and another one right here, and then kind of another batch back in here, and then what's along the cold front back here. So it's very disorganized, which is really good. And as we head later on into the evening, the fact that it's disorganized right now, it's really running out of time to get itself organized and produce severe weather across the area. Yes, there could definitely be isolated instances here and there where any of the more individual segments or cells in this area get their act together. But the fact that it's really disjointed, I don't really see this being a huge severe weather issue later on tonight or into early tomorrow morning as well, which is really good news, to say the least. The only concern that I would have potentially would be these southernmost cells. Let me switch over to the Jackson, Mississippi radar real quick. So as you get further south, you're getting less dynamic support, but you're getting a lot more instability to work with. So I would say that probably unless this line gets its act together here just to the west of Jackson, your severe weather threat is probably just going to be along and south of that line through the remainder of the evening and into the early overnight hours. That's just how it looks right now, given the fact that this is where the more robust cells are, and as you head later into the evening, where the greatest instability would end up residing. So while yes, basically all of Mississippi and at least along into the west of Interstate 65 from Huntsville to Birmingham and Montgomery and even Mobile to the west, you still have a threat. The fact that it's really not being materialized right now, I find it hard to believe heading later on to the night that it actually does get its act together. I will say real quick, if it gets its act together here in the next 2 hours or so, it's still going to be too little too late because, again, the sun's going down, and so our instability is naturally going to start falling off. So there could be a brief period, maybe an hour to 2 hours before it gets to the state line here, where it could tick up a little bit again. But the fact that it's all disorganized right now, I really don't see anything happening. If I had to put a percentage on it, the percentage chance that this thing gets its act together and actually produces severe weather across eastern Mississippi and western Alabama is probably around 10% right now. I don't really see much anything happening. And in fact, the overall severe weather risk for our area was already on the lower side anyway. So just even bump that down several notches. So it's still above zero, but it's at this point I say it's as close to zero as you could possibly get.
And thus the reason we were issued under a marginal risk.
Yes, exactly. So just look, yeah. Go ahead.
Okay, this is the way I kind of like to look at it. A marginal risk would be anywhere from, I would say, 1% up to 20.
Mm-hmm.
And then go on up from there with the risk areas from the SPC.
Yeah.
So, your marginal risk is only going to be probably about, 5, 10, or 15% chance of seeing a severe storm.
Right. And if I think a lot of people get confused on some of the Storm Prediction Center stuff. And what I can do real quick is I can let me pull it up here on this other side, and I'll flip around the screen. All right, so now y'all are seeing this.
Okay.
So when we go into the day one convective outlook here, so you've got, this is the current outlook. So you've got the enhanced, the slight, and the marginal. But what it is, it's just a probability. And so here are your tornado probabilities, and see the highest highlighted is 10%, 30% for wind, and then 15% for hail.
And
So
honestly, that enhanced risk did not pan out today.
right, exactly. So if I had the chance to change this right now, it would probably be more. I would still keep the slight risk
Right.
in place because there's still some decent wind fields out there. If things go a certain way here, it could take things up a little bit.
Hey, man, earlier, I don't know if you saw this or not, but earlier there were far more tornado warnings in the slight risk than in the enhanced.
Exactly, and that was one of the things you had going on there was when you had the cells develop, they were more individual. So you had the
Yep.
more supercell characteristics going on. And then we knew that it would eventually merge into a line, but it
Yep.
really just fell apart before it even could get its line
Yep.
going. But quickly back to the risk categories. So when you look at the overall risk, and we can go to the day 3 real quick. So here's the overall probabilistic risk. So the marginal risk you have the 5%, the slight risk you have the 15, and then in the enhanced risk you've got the 30%. So
Yep.
what that means is that in that 30% area, there's a 30% chance of seeing severe weather within 25 miles of a given point. So that basically tells you in a nutshell that the chances of you actually seeing any type of severe weather at your house, whether it's damaging winds, large hail, or a tornado, the percentage of that is pretty low. It's still low. It's still 30%. So that's just for that one single point. And I think one of the disconnects that happen here is that people look at this and they kind of associate it with the percentage of rain. And I can see why obviously people will go in that direction because that's the other thing that we give a percentage for. But
Yep.
it's a completely different percentage type going on than just a chance of rain. So one of the things I like to point out is that even though any point in this area within 25 miles you have a 35% or a 30% chance of seeing severe weather, I point to this: when watches are issued, they're issued for a larger portion. And so you see your hazard down here. So this is the current tornado watch going on. And you see the tornado likelihood is high, moderate chance for a strong tornado, high chance of severe wind, and then so on and so on. Well, then they give probabilities on that. And so then this is the entire watch area. So you go into the watch area, and the probability of 2 or more tornadoes is 70%. The
Right.
probability of 1 or more strong tornadoes is 40%. The chance of seeing 10 or more severe wind events, that's damaging wind damage going on, 80%. So that's a larger disconnect, and people are like, well, what happened to the 30, 15, and stuff like that? So
Yes.
the best way I can describe it is that when you deal with these outlooks in that enhanced risk, that is basically saying there is a 30% chance of anything happening within 25 miles of a point there. That's what it specifically means.
Yes.
But when you look at the entire risk as a whole, take that 25 miles and now expand it to encompass the entire diameter or circumference of where that risk is at. So now instead of saying that the chance within 25 miles of a point, now look at it as the chance of severe weather happening within, say, 100 miles of a point or wherever. That percentage will go up. So that's why when you look at these watches, we'll go back to the current watch going on right now. That's why you see that if within this watch, because the watch is big. When it was first issued, here was the watch. It went from basically northern part of Arkansas all the way down to south of Shreveport, Louisiana,
Yes.
just near College Station, Texas. So that's a lot of area going on there. So that's why you get the probabilities of in that entire area, there's a really good chance of having of at least one tornado, and there's also a decent chance of having one strong tornado. So it all looks depends on the how close in you get the circle, how close in you draw the circle. So you draw the circle where the whole tornado watch is.
Yep.
There's a 70% chance of having a tornado, or at least two or more tornadoes in that zone. All right. So now narrow it down to your house, and your house is a very, very fine point. So then the chance of you actually seeing one of those tornadoes coming down your street, going over your house, that's probably only about 2%
Yes.
or so. So it's when you look at it on a bigger scale, the percentage is higher. When you look at it on a very smaller scale, the percentage is lower. That's just because of your likelihood of actually seeing it. It's the same thing as just as winning the lottery. If you throw in so many tickets, your probability is going to go up, but your
Yes.
probability is still going to be like one in 50,000 or whatever that you hit it. Same concept with this. Decent tornado risk today. I know it didn't really materialize, but let's say it did. So the Mother Nature is putting in, buying a lot of these lottery cards for these tornadoes. So the likelihood of actually getting tornadoes today is pretty high.
Right.
But still, the likelihood of your house actually getting one of those is still relatively low. So, it's all the probability stuff, and really, in a nutshell, this wasn't intended for public viewing at all. It's just the magic and greatness of the internet that we have, that people are allowed to see it, which is not saying that it's wrong. It's not wrong at all. It's out there for the public to see and stuff. But the science behind it that created it is much more oriented to us in the weather field, where we have a better understanding and education on it than the general public do. So that's why there's a disconnect there with how all these risk categories get into place, and what it all means, and stuff like that. So we try our best to give you guys the information and how to kind of explain it and comprehend it. But the fact that it's still a mathematical probability, that's based on A, B, C, and D factors, it can be kind of difficult to um, express in a way that people that the everyday person can understand it.
Well, let's go on ahead now and take a look at what we can expect for Friday, because that one
Yeah.
looks more robust.
Yeah, so here is the Friday outlook, just real quick. And we actually had something that we don't really see that often happen today. And so usually what happens is when the day 3 outlook gets updated only once per day, and that is after midnight. And so we actually had a special update happen at about, I think it was about 3 o'clock today or so, mid afternoon, and they introduced an enhanced risk here across parts of eastern Louisiana and southern and central Mississippi here. So again, that's your 30% risk for seeing severe weather. So that is, excuse me, that's definitely, with being this far out, that's significant to have an enhanced risk already in place. So when we look at the overall support and dynamics and everything you have to look at regarding severe weather, is definitely more impressive than our risk tonight. But one of the things I was talking to you, Stingray, before we
Mm-hmm.
went on air here, one of my question marks for this, and it's going to be the timing. So what we'll probably see during the day on Friday, this is noon on Friday, we'll probably start to see showers and storms, kind of your pop-up summertime variety due to the heating of the day going on here. So about 4 o'clock in the afternoon, we'll probably start to see these showers and storms develop across basically the entire area. And if you get under one of those could be strong. There's some decent instability present during the afternoon and evening. So you probably see some gusty winds, maybe some small hail. But I would say the overall severe risk during the afternoon is going to be relatively low. The only way you're going to get a severe thunderstorm warning Friday afternoon and evening is going to be just like we deal with in summertime, meaning that the updraft got really intense. It's producing some large hail, mainly quarter size, and could have some damaging winds. And then it will quickly die out within a matter of about 10 to 15 minutes. So that's kind of your threat during the Friday afternoon time frame. As we head into Friday evening, this is where things start getting a little bit more interesting. So this is about 9 o'clock, 10 o'clock at night. We'll start to see showers and storms get more robust here across parts of eastern Oklahoma, northern Texas, and into western Arkansas. And then that starts getting its act together. But by the time it does, that's midnight and that's 1 a.m. So this is, according to the model data here, when it really starts getting intense, it's going to be during the overnight hours going into Saturday morning. So that in itself is a question mark for me regarding timing, because it's happening in the where you're having no sunlight, it's dark, and naturally your instability starts going down. Now here's the catch. Take a look at the instability values at 1 o'clock in the morning. I'll go ahead and say it's been a long time since I've seen instability values like that at 1 o'clock in the morning. There's Kate values. If this is indeed realized, you're going to have Kate values right along this line in Arkansas of about 3,000 at 1 o'clock in the morning. So that's due to the fact that it's going to be really, really moist dew point wise out there. Here's the dew points at 1 o'clock in the morning. And there's probably going to be dew points here in the lower 70s.
And that's going to be 66 over Tuscaloosa.
Yes, and so you're going to have 70s over here where the line is getting its act together. But then across Mississippi and Alabama, especially the western part of Alabama, you're going to see dew points well into the mid to upper 60s. So just the fact that you're getting those higher dew points, you're going to have the fuel available. So just by looking at these two things, I know that the timing is still a question mark, definitely, because it's happening in the overnight hours. But instability doesn't appear to be a question mark with this. So you can kind of check that off on the severe weather checklist for things that we need. So you can go ahead and say instability, check on that. One of the other issues, go ahead.
If it's sitting there at 1 o'clock in the morning over Little Rock, Arkansas, and if it's one of those that are moving like at 30 and 40 miles per hour, it may not reach West Alabama until about 11 or 12 the next day.
Right, and that introduces another element to this forecast.
Yeah, exactly.
With the fact that it gets its act going late evening, overnight hours, and then by the time it starts getting to our area, this is the last image of the high resolution NAM. It only goes out 60 hours, so this is the last image of it at 1 o'clock Saturday morning. But if you extrapolate this out, if it's moving at about 30 to 40 miles per hour, it would not reach the state until after daybreak on Saturday. So then what happens when the sun comes back up? Well, there you go. Now you're allowing for more heating to occur. And even though you would have cloud cover around, more than likely, you would still be able to warm up a few degrees. And the fact that one of the tricky things is the temperature and dew point difference. When you have a temperature of 65 with a dew point of say 61, your instability values are going to be pretty limited unless you have some really good upper level support. So just taking that aside, if you're looking strictly at dew point and temperature, 63 temp, 61 dew point, not really going to see that much instability. But then when you bump it up to about 70 temp and 70 dew point, the dew point being in the lower 70s, that increases the instability greatly. So even just having 70 dew point, 70 temperature, say at 5 o'clock in the morning, that's significant enough. So sun comes out, but it's cloudy. So then your temperature, say, only goes up to about 72 or 73. That actually greatly increases that instability based on those 2 to 3 degree differences because your dew point is that high. Your dew point's at 70, and that dew point's not going to budge. The only thing that would budge would be your temperature. So, that's just something else to kind of think about is, even though you might not see a lot of sunlight on Saturday, the fact that you might be sitting at 70 temperature to 70 dew point, if you only warm up about 3 degrees, that 3 degrees is going to very much increase your instability values
Look
that
at
are
the
already
GFS.
pretty good.
Check out the GFS.
Mm-hmm. I would, if I had to bet my money on something, you're probably just looking at a nasty squall line moving on through. And yes, there could be maybe a couple of cells here and there that could develop out ahead of it. So that is going to be
Cape.
Yes, and that's going to be at 3 o'clock or 4 o'clock in the morning on Saturday. What's the EH high? Yeah, and so that's decent too. So that's going to be what you would look for tornado potential.
Yes.
So it's very interesting. The thermodynamics definitely look to be there, even with the timing of it being overnight and then moving in during the morning hours and day on Saturday. So I don't really think instability is going to be much of a question mark with this.
Yes.
The questions that I have though are regarding the wind fields, and so I don't know if you can click on say Western Alabama for a sounding.
Yes.
Real quick. So this is going to be a sounding at 4 o'clock in the morning. So if you zoom in, you notice how the low levels you're getting winds coming out of the southeast. So that's good. But one of the questions I had was some of the high resolution models. Once you went up in the atmosphere, things got a little kind of jumbled up or junky, if you will. The wind fields didn't really completely veer; they kind of went back a little bit. So when you have that effect, sometimes it can mess up the organization of the storms. But if the GFS sounding is correct, yeah, there would definitely be some pretty nasty storms across the area on Saturday. So again, there's still time to watch it. I don't really think this would have a major high end impact like what we saw a couple weeks ago with the several long track violent tornadoes that happened across our state. I can see this being much more of a damaging wind maker as opposed to a significant tornado maker for sure, especially with things being in the form of a squall line. So I mean, we got time to watch it. So we'll have time to look at more data, kind of get more, just kind of a more better idea, if you will, or better idea of how things could take shape on Friday night to Saturday.
So it's going to be real interesting, isn't it? And here is, like you said, this batch of storms here. Right there over Louisiana too. We'd have to watch those as they come on up.
Yeah, and when I quickly did an analysis on those, they look to be elevated somewhat. Right. The cloud bases would be pretty low to the ground. So I would say that if you're going to get a threat with that, it would be more hail with that first batch. But when you look at this high resolution data, especially along the line, one of the other things that kind of stands out to me is the fact that it's hinting at you're going to have a mid-level inversion. You're going to deal with some warmer temperatures at about the 700 millibar level, and yeah, right there, right, you see where the red and the green, the lines, they start going in opposite directions. It's good to have the green go to the left if you're wanting severe weather in that zone, because that allows for evaporative or some evaporation, cooling, evaporation processes going on, and it helps to increase the instability. But notice how the red line there juts off to the right. So that's one of the questions that I have, and that goes back to the timing as well. Because if you have an inversion already in place at 1 o'clock in the morning, uh, the only way you would burn off or get rid of that inversion would be cooling the temperatures up there. Uh, the way that you get it for most severe weather events is when they happen during the day, you erode that, what we call the cap, with the surface temperature getting warmer than that temperature up there. And it's 1 o'clock in the morning. There's no sunlight, so the only way you would erode that cap would be the cooler air aloft moving on in and dropping that temperature down from, say, 75 down to, say, like 60 or so, where you don't have the inversion anymore and everything's able to just lift freely through there. So that's another question mark that I have, is what would if we do indeed have that mid-level inversion, how bad is it? How much what we call convective inhibition would be in place, meaning that you have to get over the convective inhibition limit in order to get the updrafts to form and get organized and get strong.
Observed tornado just north of Bastrop, Louisiana.
Yeah, I've had that. I've had my eye kind of watching that cell off to my left here. It definitely has a what we call a bookend vortex look to it. When you look at the reflectivity, it's not your typical classic supercell structure, but you definitely have an area of rotation on it. So it's kind of just this just area spin that's developed there, kind of in that little notch back in there.
Yes.
So again, that's that. Going back to what we talked about to start off the show, if there's going to be severe weather issues, it would probably be with that batch right there and south, especially heading into the overnight hours, because that's where the better instability is gonna end up being.
Dude, look at this. Look at that comma shape right there.
Yeah, and you're probably getting dual threats here. So not only do you have the tornado on the ground right where the little notch is right there,
Yep.
but what's happening is you're getting what's called an inflow jet on the back side of things, and what that is doing is that's pushing out that bow echo right there. So you're getting your classic bookend vortex where the comma head is. Draw a point there, and that's where your tornado is going to be. And then anywhere along that line, that bow, you're going to get damaging wind potential as well.
That's real muddy though. That the correlation coefficient and
It
that
is, and you're looking pretty high up too. So the only way you would see it that far away
Ooh,
would
look
be
at
as
that.
it's a strong tornado on the ground. Yeah, and that's a pretty intense couplet right there. Let me quickly look at
Yeah,
my
let's
radar here.
look at your radar too. So we'll I tell you what, we'll switch back over to yours.
Here, let me switch over to and share that screen. What I need to do is I need to switch to the Shreveport radar. All right.
And heads up over here, if you're watching us in Hollandale, Mississippi, or up here towards Greenville or anywhere like that, this storm is coming towards you here within the next 30 to 45 minutes.
Yeah. So I've got the Shreveport radar up, and one of the things I want to look at is the shear rate, and it's in that dead zone. Let me loop it. Let me loop it and see. So real quick, you had a little bright spot right there. But your tornado is going to be, it's right in this area. So yeah, shear rate's going to be kind of jumbled up because you're kind of in between radars here. Actually, your tornado is going to be back in It's going to be back in here.
Right.
So, yeah, I mean that's definitely one of the storms you'll have to see. Basically, now what you're probably gonna watch for is which cells start outperforming the rest, if you will.
Right.
Which ones actually end up becoming the more dominant ones, can last long, and can actually produce some severe weather. So
And
I can
see,
go quick. Go
dude,
ahead.
that one right there has literally nothing to the south of it, and it is tapping into all of the moisture that's coming up near Monroe, Louisiana.
Yeah, and when let me take a look at the. Okay, it hasn't moving at 45. I could do a storm track real quick. So here's 45, and we'll take it out. We'll go an hour because I really don't see this storm really weakening much. The good news is there's really no uh, major town. Let me update it.
The
Here's
first big one would be Greenwood, Mississippi.
Yeah, and so most of what you're going to get here is these smaller communities and stuff. So here's your storm track going out an hour. So again, most of these are just going to be your little country out in the country communities and stuff. I would, you have that observed tornado on it, but the way that it looks, I would really be worried about dealing with some damaging winds here along the leading edge of that line. So yeah, you're
Yes.
going to have a tornado back in here, but that's a pretty decent bow echo here. So what you've got is you've got winds that are kind of punching in back in this area at about the 700 millibar level. That's
Yes.
usually where you start getting these, and it's taking that momentum, that wind speed up there, and it's pushing it out. You're making that bow echo, and then what happens is the inflow coming in here, the bowing out pushes into it, and then it gets right back, and so you start getting an area of low pressure that develops. But yeah, definitely would be concerned more about some damaging wind potential here on top of having that tornado threat. So good news is, like you mentioned, there's really no big uh, town or city here or well populated area that would be concerning. But still, I know people live out here, so they need to watch it.
Well, man, that do you have anything else you want to add before we wrap up?
Yeah, just another quick note on tonight. Again, we're going to have to watch this entire line, or just basically just giant area of storms now.
Yes.
I mean, you're going to have. We can switch over to the Memphis next ride again. So for northern Alabama, these are going to be your storms, and they're really just jumbled up. One of the things I will say this, I haven't mentioned this yet, but one of the things that the model guidance had been hinting at a lot is it was saying that this would have its act together by now, but it would eventually fall apart like it already has. And what you would have to watch for would be this line back here with the
Yep.
cold front. So get through this round first. We'll see how long this can manage to get to stay together. But once it starts getting into this area, well, something updated there. That's why it froze. Once you start getting into this area, the instability is going to go way down. So most things are probably going to end up being elevated. But the thing is to watch then would be, again, timing issue. This front back here would be moving through more during the morning hours when the sun will start coming up, um, especially across central and eastern Alabama. So that if I would say at this point, if there's uh, take the first round out, the severe weather risk would probably be with that back end line,
Yes.
especially heading into the morning hours. So again, unless this first wave gets its act together, which I really don't see happening, um, all eyes would start to be on that back end right there. So if I had to back things out and kind of draw an area where I would think the greater severe weather potential would be for the remainder of the evening, I would say it's probably going to be south of that line. Because again, once you get later into the evening and stuff, the greatest instability is going to be down here. So I would really be more concerned about these cells down here moving across this area right here. So that's the way I see it right now. The greatest severe weather potential, even though it's still on the lower end of things, is going to be along and south of that line. But one thing we'll have to watch is if when we get into the morning hours and early afternoon hours on Saturday or on Thursday, this cold front right here is going to start moving in right here. So you're going to get an increase in moisture out ahead of it. You're going to get the daytime heating effect, and you're going to start to get instability values rising along this area. So there could be, there's a lull in the severe weather threat right now, and it probably wouldn't increase once again until we get into tomorrow morning and afternoon, and it would be across more eastern Alabama. So that's something we'll have to watch for. And then, of course, we get the system moving in Friday night to Saturday as well. And then the good news is, after that, I really don't see a big severe weather risk for a while. It looks like it. We look to stay in an active pattern. There probably will be chances of rain, especially closer to the coast, for multiple days next week. There could be some shower and storm activity moving in mid to late week for more majority of the area. But just looking at model guidance and stuff, there's nothing that really stands out beyond the Saturday system, which is good news again. So hopefully after this, even though the pattern would still be kind of active across the region, I don't see a big time severe risk with any of them.
Man, that's going to do it for this edition of the forecast with Stingray and TP. We've gone about 45 minutes. We hope that you guys have enjoyed it. And as always, you can follow us on social media, and we will be doing severe weather coverage in the event that there is tornado warnings in our area.
Exactly.
So, well, man, that's going to do it. And we here at the forecast hope that you guys have a great rest of your evening. And as always, God bless.
See you guys.